All right, here's the first list of questions that people had. I'm going to start with question number 5, and I'm just trying to pull up the question and show you the work at the same time. So here's the question. Assume that events A and B are in the same sample space. Under what conditions is the probability of A union the probability of B equal to the sum of those two? Well, if you look back in your notes, we have essentially two formulas. When the events are mutually exclusive, that's when we truly can take the probability of A union B is simply the probability of A plus the probability of B. Now, when they are not mutually exclusive, so when there is some type of overlap, that's when we have the second formula, which is actually on the back of your notes. In that case, we have the probability of A or B is the probability of A plus the probability of B, and then we have to subtract their overlap, which is the probability of A and B. So again, mutually exclusive, I get to just straight up add the two probabilities. Not mutually exclusive, I have to turn around and subtract their overlap. All right, moving on to question 6b. It wants to know you've got your two fair six-sided dice. X is the first dice shows a 1, and Y is the sum of the numbers on the dice is 5. So if you have your two dice sum out, that might be helpful. I do not have one here in front of me. So if we can go and visualize 1, 2, 3, 4, 5, and 6. And it wants to know, when are both of these happening? So first of all, let's pretend this is my first die. If I want a 1, that would be all of these right here, and there are 6 of those. And I want the sum of the numbers on the dice to be 5. So if you can envision, right here would be a 1 and a 4, which would be a sum of 5. So when do both of those happen? Just at that location right there. So your answer is just 1 time for question 6b. And let's go ahead and do A just while we're at it. On A, it says we want one event or the other. Well, if you take a look, here the 6 times that you have your first die to be a 1, and then the second event was the sum is 5. So that would happen here, that would happen here, or here. So 1, 2, 3, and we end up with 9. So going along with C, because they have an overlap of that one spot right there, then their events are not mutually exclusive. Let's go do one more. So we've done 5, 6b. Let's go take a look at number 9. Okay, number 9 says, it's estimated that about 10% of males in the U.S. are left-handed. Identify a complement. A complement is the opposite of that. So the opposite of being left-handed would be not left-handed. So not left-handed. So if 10% of the males are left-handed, that would mean 90% of males are not left-handed. I think I'll wait and do 11 because I can see it's a formula. Let's see if we can go down to question 18 and answer that one for you. And that one looks lengthy as well. So I think I will stop here. Actually, let's go down and take a look at 20. If an experiment has only 3 outcomes, X, Y, and Z, the probability of X is A, the probability of Y is B, what is the probability of Z? Well, if you have 3 outcomes, then the probability of x plus the probability of y plus the probability of z has got to equal 1. So the sum of all of the probabilities has to equal 1. Well, we're told that this probability is A, we're told that this probability is B, and we're looking for the probability of z. So we're going to simply solve for the probability of z. It would be 1 minus A minus